Hello, monad lovers. So let's see if we can finish off the structure needed to make the free monad really a monad. So before we had seen that we made it a functor, and now I would also like to have the monad structure. So a return, we said previously, we get for free. We asked for it, so we already have a return, but we do need to define a join, which takes two FreeMs and turns it into one FreeM, right? And the way we usually do this is by pattern matching on the X. Right? So you see that if we have a return here, then we can just use the inner X, which already has this type, as our overall thing. So from when we were thinking of these things as terms before, we're saying that we're forgetting the fact that we were treating this as a variable, and now we are treating it as a term. Right? Okay, what about the layer? Here, let's see, so we have an X, which has this complicated type, and we want to make a free MD of X. So we can't use X directly, right? I could try starting to pattern match on the D, but that seems dangerous. So I think we have to make a choice. Should we do a return or should we do a layer? And if we do the wrong choice, then here we really have to produce an X. We have no way of making an X out of all this, right? So that's not going to work. But if we do layer, then here we see that we have some chance, right? Because now we have to make an args of D, and we have an args of D. So if we use the args map, D something X, that's going to work if only we can fill in this function, which again looks like one of these recursive calls, right? But now you already know what's going to happen before I fill this in. It's not going to pass the termination checker, because how would we know that this is applied to smaller things? Well, we do, but Agda doesn't. So in order to also make Agda happy, we do this mutual trick again, right? Now, I'm not going to do this. I am going to fill in the args map that I have, but I'm going to specialize it. So here, it's all mutual, so it's in here, and rename args map to args map double prime, triple prime, did 3 just in case. Maybe 2 would have been enough. Fine. Okay, and now I want to specialize it. So this is the type of arbitrary f, but now I want to take my f to be join of D, right? So that means that this is going to be my X, and this is going to be my Y. So I don't need an F anymore, but I know that I'm going to start to go off the diagonal eventually and not keep this D, which I'm pattern matching on here, right, the same as this D, which is fixed through the whole construction. So I also need a C I can keep fixed to use for these things, like that. And I don't need a Y anymore, and I don't take an F. Figure out what to do here. Okay, and here I wanted to specialize this to be the join D. Well, I don't have a D available. That's my hidden C, and then X. Right. And now if I do this, then that fits. Just doing the thing I did before, but I'm making it with a copy of argsmap, which I'm defining mutually, so that I can call the join here and I can call the argsmap here. So that's the mutual definition. And we pass the termination checking because here join is applied to this x, which is definitely smaller than layer x. Right? So that's why it makes sense. Okay, and now we could go ahead and also prove the laws, but doing that would just mean more of these mutual definitions where we have to prove something about join and then specialize the fact about argsmap at the same time mutually. So I don't think that's particularly insightful. Let's just call it a day instead. And see what we've done. We've actually managed to construct a free monad for any functor of the form args of d, right? Which we know that we can't do for an arbitrary functor. But now we have restricted to a nice class of functors where the free monads does exist. So that's possible. And if you squint in the right way, you'll also see this occurring in the coursework again, which might be helpful or might not be helpful, but it should at least give you some experience of these things. I hope you enjoyed.